Hello, my name is Jacques, and today we're going to continue learning the basics of the Bevy Game Engine. Bevy is a simple data-driven game engine built in Rust. It's free and open source. This tutorial is the 9th episode in my Learn Bevy 0.10 video series. This episode builds on what we learned in the previous episodes. If you've been enjoying this series so far and finding it helpful, please consider subscribing and sharing it with your friends that would also be interested to learn how to make games and join the Bevy community. Today, we're going to be continuing with our Bevy ball game project that we've been working on. In today's episode, we're going to be learning how to handle state in our Bevy applications. We'll look at how to run systems as we enter and exit states, and how to only run systems when we're in a specific state or in a specific set of states using run conditions. State management is a very powerful tool in our Bevy tool belt. We'll use state management to create a main menu state and a game state, as well as keep track of whether our game is running or paused within the game state. Let's hop back to our code and get started. Before we begin learning about state, I want to first move all our current plugins into a parent plugin called the Game plugin. This will help us differentiate between our components and system that belong to our game and those that belong to our main menu, which we'll also make in a bit. Let's do this refactor now. In the source directory, I'm going to create a new folder called Game, and again in the source directory, I'm going to create a new folder called Main Menu. Inside each of these, I'm going to create a mod file, create mod.rs, and main menu, also mod.rs. Now, we're going to break some things. We're going to grab the enemy folder, drag it into the games folder, move, same with the player, into the games folder, move, score, into the games folder, move, star, drag into the games folder, move. So now at the top level here, we've got source, we've got game, and we've got main menu. Inside the game module, we're going to now need to declare our enemy, player, score, and star modules. We can actually just copy and paste it from here. I'm going to move that up so I can simply cut that. Back to game module, put those in. Now let's create a game plugin. We say pub_struct game plugin, semicolon. Now we need to implement the plugin trait for the game plugin. We need to satisfy the build method. Looking at our main.rs file, we just need to add in our plugins like we did before. We can actually also move in this game over event. Let's do that now. Let's grab these, cut, game module, app, paste, add plugin, add event. I'm going to add some comments here just to make things a bit more clear. Looking at main now, we need to clean this up. Notice we now have, in our top level, we've got a game module and a main menu module. We need to add that to our main file. Say mod game, mod main menu. That looks happy now. We're no longer using events here, so I'll just remove it. We need to now add our game plugin and our main menu plugin here. Oh, first we need to go create our main menu plugin. Go to main menu module, use Bevy. For now, we don't have anything else in here. That's fine. This is going to be empty until we start building out UI. For now, it's just going to hold the following: main menu plugin, semicolon, implement plugin for main menu. We need to satisfy this build method. Let's create an empty system for now, just called main menu. It's not going to do anything, it's just going to print out main menu. Again, we'll use this once we start creating UI. App. Just to test this out, we'll add it as a startup system. And that's it for the main menu plugin for now. Let's go back to main.rs and add our two plugins. We'll add some comments here to clean things up. Here I want to add my game plugin and my main menu plugin. I need to import both of these to use them. We've got the modules up here, we just need to use them. And we'll just grab the game plugin and the main menu plugin. And there we go, that should be fine now. Now we've got some errors here. One thing we're missing here is the game over event, which we want to get from this top level crate. So we'll just say use crate events, game over. That's how we're getting that. Save now. Okay, that error went away. Oh, you know what it's yelling about? We're missing Bevy. Use Bevy. There we go. Save now. That looks good. Why is it mad at these? When it gets mad like this, just cargo build so you can see the errors better. Back to our main menu module. We forgot a semicolon there. Back to our game module. Looks like that other error went away. Sometimes if you have an error somewhere else in your project, it can trigger weird behavior with your IDE. Just something to note. It looks like the game module is fine now and we didn't actually have an error there. Let's look at our enemy module next. What's this mad about? Here in the player systems file, it looks like this is the source of our errors. We need to update these use statements. We're now using crate game enemy, and same for these ones as well. Use crate game enemy, game score, game star, save that. Let's try cargo build again, and there we go. This is a unfortunate case of where our IDE is bugging out, but our project's actually fine now. You can see when we cargo build, everything's fine. I'm gonna just try exiting out of my IDE and hopefully that gets rid of these errors. And what do you know? Closing out and just opening VS Code again, everything's fine now. If we cargo run our app now, there we go. Everything works just like before. Now that we've done that small refactor, we can get to the meat of the video. Bevy states. States are another powerful tool in our Bevy tool belt to control when and if our systems run. States are a control flow mechanism for managing our applications. We can use state to run a system when we enter or leave a state, or to run systems only when we're in a certain state or a certain set of states. Perhaps the most common one is our game running or paused? We don't want our enemies and the player to be moving when our game is paused. We don't want more enemies and stars to be spawning when our game is paused. That's a great case for using a playing and a paused state. Another example is that we don't want to spawn our player and our enemies and our stars when we're on the main menu. That's an entirely different state from playing the game. You can see more examples of using state on the Bevy GitHub page. I'll post all these links in the description below. But I think the best way to learn states is through seeing the following practical examples we're about to write. We'll now look at how to use state in our game. Let's hop back to our code and get started adding state to our game now that we have a main menu plugin and a game plugin. I want to start by creating an enum called appState. AppState is going to have three cases: the main menu, the game, and game over. This will control whether we're in our game, or if it's game over, or if we're on the main menu. Now to have this function as a Bevy state, we need to derive states. This tells Bevy that appState is going to be a state. Quickly looking at our player module, remember here how for our movement system set and confinement system set, in order to derive system set, we also had to derive the following Rust traits to make system set work. We have to do the same thing to derive states properly. We're going to have to also derive the following traits to make the states trait work: debug, clone, copy, EQ, partial EQ, hash, and default. Again, you don't need to know the intricacies of these, just that we need them to make this one work. We also want to declare a default value for our app state. We'll set the default to be main menu, because when you open a game, you're usually on the main menu. We do this by writing #default above main menu. Now, let's add the appState state to our game. Still in our main.rs file, after we add our Bevy default plugins, but before we add our own plugins, I want to add the state. We're going to call .add state, turbofish syntax, appState. Now our Bevy application is aware that we have appState, and it can be any of these three values, but it's defaulted to main menu, so that's what it is right now. I want to make another piece of state specifically for the game, whether it's running or paused. Let's go into our game module and create it here. I'll call it pub enum simulation state. I like to use the word simulation state over game state because there's games where you can still be playing the game, but you can pause and play while you're performing actions. So for that reason, I like to use the terminology simulation state to indicate whether a game is running or paused. But that's just personal preference. So I'll say here, for the two cases, running is the first case, and paused is the second case. Again, derive states, and then to make states work, we also need to derive debug, clone, copy, EQ, partial EQ, hash, and default. Now for the default state for simulation state, I'm actually going to set it to paused so that we have time to move our window where we want it on our computer before we start playing our game. So I'll set paused to be the default value. Just like we added app state to our app, inside their game plugin, I'm going to add simulation state. I'm going to do it above the event here. Add state, turbofish syntax, simulation state, parentheses. There we go. Now our application is also aware of simulation state and that it's currently set to default. Now, before we dive into our individual plugins, meaning enemy plugin, player plugin, score plugin, and star plugin to make our systems depend on the state we're in, I first want to add in the logic to toggle the simulation state between running and paused. To do this, in our games module, I'm going to create a new file called systems. Systems will be a module of the games module. We'll say use Bevy. Let's take one step back and go to game module. Let's declare the submodule here, mod systems, and we'll just say use systems star to grab everything inside there for now. Oh, I made a small error here. .rs, and there we go. That fixed that problem. Okay, back to game systems. I want to create a system called toggle simulation. Now for our system parameters, first off I want commands, you'll see why in a second. Next I want keyboard input, and then lastly here, something we haven't seen before, is I want the state resource of type simulation state. This is how we can read what the current state is of a particular state in a system. Let's first check for keyboard input. I'm going to set it to be space to pause and unpause the game, but you could also probably set it to be escape. Actually, that's a bad idea because that's what our exit game event is tied to. So just use space along with me for now. If keyboard input, just pressed, key code space. Now let's check what our current simulation state is. If simulation state, first value, this is to get the current simulation state, because this, remember, is the state resource, and to get this, we need to get the first value. Let's check it against simulation state running. So if the current simulation state is the simulation state running, we know that that means we want to pause our app because it's currently running. So we'll say commands, and here's something we haven't done before. Insert resource. What do we want to insert? We want to insert the next state resource, and this is going to require an optional value of the type we want to pass in. So we have to say sum simulation state paused semicolon. Notice here it's getting mad because we don't have this in the scope. Let's import it. Use create game simulation state, because that's where that lives. Oh, I have a typo here. Simulation state running. Finally, I'm just going to print here. That handles the case where we're currently running and we want to pause our game. Let's add the opposite case now as well. If simulation state resource dot simulation state equals simulation state paused, again, commands, insert resource, next state resource, as an argument, sum simulation state paused. And now I'll print out that the simulation is running again. And there we go. Our toggle simulation system is done. Let's register this with our game module. Game module. After our plugins here, we'll say systems, add system, toggle simulation. Now, let's start using our states. We only care about toggling our simulation if we're actually playing our game. So this brings us to using a run condition to check which state we're in, and if we're in that state, to allow our system to run. A note on run conditions. Runif is a use case of run conditions, where the runif method takes in a system that returns a bool. In our case, we'll only be checking if we're in a specific state or not, but we can use them with any system that returns a bool. We can also chain runif with not and also or else to get some really complex behavior, but for now, we're just going to be using it to check for specific states. Let's do that now. I'll also be posting the link to this article below. Now, let's use a run condition to run our toggle simulation system only when we're in the game variant of our app state enum. I'm simply going to add a run if method here on my toggle simulation. Remember, your parameter for your run if can be any system that returns a boolean. In our case, we're just going to use the inState method to return true or false if we're in the state we specify. Again, we only want to run our toggle simulation system if we're in our app state game. Don't forget to import this. Use create app state, since this is just living in our main.rs file. Save, and there we go. Our toggle simulation system will now only run if we're in the app state game state. Let's keep going. I'm going to add 2 more utility systems to our application before we start adding state to our plugins. In source systems, we're going to add 2 more systems here. Transition to game state system and a transition to main menu state system. Let's start filling out our system parameters. For the first one, we're going to want commands and then keyboard input. And then again, we're going to want to look at our current state of type app state. Here in our system body, let's first check for keyboard input. We'll say if we hit the G key on our keyboards, we'll transition to our game state. We'll do this by writing if keyboard input, just press key code G. Next, we want to check our current app state does not equal the game state because we don't want to transition to our game state if we're already in it. If we've passed that if check, we want to write commands insert resource, next state, some app state game to transition to the app state game state. I'll also just print out entered app state game so that we know this has happened. Here, app state is currently not in scope, so let's import it. Use create app state. This is because this just exists in our main.rs file. It's not in a submodule, so we just get it using that syntax. Now back to our transition to main menu state system. This is going to have the exact same function signature as this one, so we'll just copy paste. Inside the body of our system, we'll copy paste this as well. Let's say we want to transition to the main menu if we hit the key code M. If the app state does not equal main menu, we'll push the main menu state and we'll say entered state, app state, main menu. Let's register both of these systems with our app. Go to main.rs. Let's add them here with our systems. Go to game systems. Oh, I have an error here. For running, we want to pause. For paused, we want to go to running. Cargo run our application again now. If I hit G to go to my game state, now if I hit spacebar on and off, I can toggle my simulation state because this run condition is now passing. Okay, now let's actually dive into these systems and make them depend on our states. Let's start with our enemy plugin. Let's go to our enemy plugin and let's start with our systems. We'll come back to our spawn enemy system in a moment. But for now, let's start with these ones. On each of these, we could do what we just did with our toggle simulation system and do the following. We could say run if in state app state game, because we only want these to be running when we're in our game. And here I'm just formatting this a bit so you can see it better. App state is out of scope, so let's import it. Use create app state, and we can chain these run conditions. So we only want to run the system in app state game, but also run if in state simulation state running. So you can check against multiple states to ensure that your system only runs given these conditions. And that's very, very powerful. We can do the same for these other systems because we want them to also only run when we're in our app state game and simulation state running. But that's a lot of boilerplate, so we're going to use a shorthand. I'm going to get rid of these 2 run conditions. Save to format. I'm going to comment these out for a second. And I'm going to say add systems. And then for our argument here, we're going to pass a tuple with each of our systems. So enemy movement, update enemy direction, define enemy movement, tick enemy spawn timer, and spawn enemies over time. Now to run all of these systems under those same conditions, we're going to say we're going to use a slightly different API. Instead of run condition, we're going to say in set on update app state game. And then also we'll chain it with inset on update simulation state running. And that gives us the same behavior as adding run conditions to each of these individually. Now, going back to game module, remember I set the default simulation state to be paused. So when we start our game now, these systems won't be running until we transition to the game state and toggle our simulation state to running. Let's test that now. And look at that. The enemies aren't moving. I can't hit space because we're not in the game state yet. So I'll hit G to go to game state, enter the app state game, and then toggle the simulation to be running. And there we go. We now have our spacebar acting like a pause and play button. But this doesn't apply to our stars yet. We're going to have to add the same logic to our star plugin. But for now, let's keep going with our enemy plugin. I'm going to remove this now, but you're welcome to keep it in if you want. We also want to only spawn our enemies when we enter app state game. We don't want enemies on app state main menu. So let's take a look at how we can run systems when we enter or exit states. Let's comment out our startup system and say add system, spawn enemies in schedule. Now as our argument, we'll say on enter app state game. Above this, I'm going to change my comment here to say enter state systems. Spawn enemies will only run once when we enter our app state game. Let's test this now. Here we're in our game. Remember, by default, we go to app state main menu first until we hit the G key. I'm going to hit G now. And look at that. We spawned in our enemies as we entered the app state game. When it's game over, we want to despawn our enemies and go back to the main menu. So let's add an exit system as well. First, let's go to enemy systems, and below our spawn enemy systems, I'm going to create another system called despawn enemies. We're going to need commands, and we're going to need an enemy query to get our enemy entities that have our enemy component. Now in the body of our system, we want to say for enemy entity in enemy query dot iter commands dot entity enemy entity dot despawn. So when do we want to run this logic? When we exit the app state game. Let's go back to game module. Here below our systems, we'll add another comment to say exit state systems, and we'll add system despawn enemies in schedule on exit app state game. Remember the semicolon there. Oh yeah, let's test this out now. Cargo run. I'm gonna hit G to enter app state game. We see our enemies get spawned in. I'm now gonna hit M to enter app state main menu. And you see our enemies get despawned. Awesome. So we've learned how to run systems within specific states or a set of specific states. We've seen now how to run a system once as we enter a state and how to run a system once as we exit a state. Now let's go through the rest of our project. We'll go to game, module, and apply the same state logic to our other plugins to make our entire project stateful. Okay, I'm gonna do these a little out of order. I'm gonna do the star plugin next. So we'll go to the star plugin. Let's start with these two systems. We'll start by commenting them out. We'll say add systems, tuple, tick star spawn timer, and spawn stars over time. We want to run these in schedule on update app state game, and also in schedule on update simulation state running. Saved format. Oops, I got the terminology wrong here. It's in set. We're going to need to import both app state and simulation state here. It looks like my IDE pulled in simulation state for me, but we still need use create app state, save, and it looks like our errors went away. Delete these two old lines here, but you're welcome to keep them if you want. Next, we're going to want to spawn our stars when we enter our app state game. I'll comment this line out. I'll create another comment here on enter state, and I'll say add system spawn stars in schedule on enter app state game. Let's make a counterpart to spawn stars just like we did for enemies. Here below spawn stars, create another system, despawn stars. We're going to need commands and our star query in the body of our system for star entity and star query.iter, commands, entity, star entity, despawn, semicolon. Let's go back to star module. Let's add an exit state system, add system, despawn stars in schedule on exit app state game. And why is this mad? I have a typo here, despawn stars. Go back to star module, save, and I think this might be another IDE error because we're definitely importing all our systems. It's cargo build check. Oh, I think I didn't save the file. Go back to star module, and this should now be fine. Cargo runner application. Remember, we're in the main menu state. Let's hit G to go in our game state. And look at that, we've spawned in our enemies and our stars. Neither the enemies nor the stars are spawning over time until we go into simulation state running. I'm gonna hit space. And there we go, stars are spawning in. There's another enemy that spawned in. I'm gonna hit pause again. And there we go, we pause. Excellent. Here in star module, I'm just going to clean this up by getting rid of the startup system. Now go to game module. We've taken care of enemy plugin, star plugin. Let's do player plugin next. Let's go to player plugin. Let's start with these systems. Now here, we already have our inset logic on these lines, and I don't know if there's a different API we can use, but I think we just have to use our run if conditions on these systems individually. So I'm going to hit space just to make this more clear. And for this first system, player movement, I'm going to add a run condition, run if, in state, make sure we're in app state game, and run if, in state, simulation state, running. Let's import these so they're in scope. Use create app state, and then use super simulation state. I'm going to do the same thing for confined player movement, so I'll just copy paste these two run conditions. We'll add them in after inset, save to format, and those two systems are now taken care of. With these two, we can go back to our add systems API. So we'll say add systems tuple enemy hit player, player hit star. Let me get rid of these two while I'm at it. Inset on update, because we want this to run once per frame. App state game. Inset on update, simulation state, running. There we go. So that's all our systems taken care of. Let's take care of this one next. We'll comment this out. We'll say on enter state, add system, spawn player, in schedule, on enter, app state, game. Let's get rid of our add startup system since we no longer need it. Let's also create another counterpart to spawn player. Here below spawn player, we'll create a despawn player system. We're going to need commands and a player query. Remember, we're only going to have one player, so we'll use an if let OK block here. If let OK player entity gets player query, get single. Now we have our player entity, commands dot entity, player entity, despawn, semicolon, save to format. Let's register this on an on exit state system. Let's go to player module. Here at the bottom, I'll say on exit state, add system, despawn player, and schedule on exit, app state, game. And there we go. That's our player plugin also taken care of now. Let's cargo run to test. And there we go. There's now truly nothing going on in our main menu. In the future, we'll add a UI here, but for now, we're just using the states. Let's hit G to go to our app state game. And look at that. We spawned in our player, our enemies, and our stars. We can't move our player yet as well because the simulation's not running. Let's hit space to start the simulation. Now I can move around. All is well. Now if I hit M to go back to the main menu, all our on exit state systems run. We despawn the player, we despawn the stars, and we despawn the enemies. We're back in our main menu. When we play our game right now, I'm gonna get some points. I got 3 points. Oh, there we go, I lost. Now look, my score is 3. The high scores get added as 3. I go back to the main menu now to reset everything. Hit G to go back into my game. Oh, look, there's 2 bugs. The simulation was running from the start. And also, look, if I pick up a star, my score is still at 4. It didn't get reset. So we need to reset our simulation state to paused when we go back, and we need to reset our score. Let's do that now. Let's take care of the easy bug first. In our top level directory, we'll go to Systems. When we transition to our main menu, we also want to make sure we're pausing our simulation. So as part of this, we're also going to say commands, insert resource, next state, sum, simulation state, paused, and save. Now when we go back to the main menu and back to our game will start paused again, like we want it to. Now, let's go to game module. We want to update our score plugin to also use state, so let's go to our score plugin, score module. All right, here's an interesting case where we perhaps don't need to worry about our state as much in regards to these 2 systems, but we will care for this one. So in this case, I'm just going to use a run condition. I'm going to say update score, run if, in state, app state game. We need to import app state game, use create app state, and now our score resource we don't want to persist throughout our entire application. We only want a score resource to exist when we're in app state game. So we're going to get rid of this init resource line here and instead go to score systems, and here at the top we're going to write 2 new systems. We'll say pub, we'll create an insert score system and a remove score system. For our system parameter here, we're just going to need commands, and in the body of our system we'll write commands insert resource. Now we've seen this before to pass the next state resource to change our state, but here we're using it for the first time to insert a resource we've created at runtime instead of when the application starts. We'll still just use score default here. Remember, this gives us a score resource where the initial value is 0. And that's it for insert score. Here in remove score, we're going to do the inverse of insert resource. We're also going to need commands as our system parameter, and in the body of our system we'll write commands dot remove resource, turbofish syntax, the score type, parentheses, semicolon, to remove the score resource. Remember, only one resource of a specific type can exist at any time, so this will remove the only score resource that exists. Now we want to run our insert score system when we enter app state game, and we want to remove it on exit app state game. Let's go do that in our score plugin now, score module. I'm going to add some comments to keep things clear. Now for our on enter state, we'll say add system, insert score in schedule, on enter, app state game. Finally here we want to say remove score in schedule, on exit, app state, game. And with that, I think we've finished adding state to our application and fixed all the associated bugs. Let's try it out now. We're on the main menu. Let's hit G to go to the app state game. We're in app state game. Our score is 0. Let's get some points. Oh, there we died. Our score was 2. Let's hit M to go back to the main menu. Back to the main menu. This should have despawned our player, stars enemy, and removed the score resource. Let's hit G to go back in and start a new game. And there we go. We've reset our score. We can play our game again. Get a couple more points this time. And there we go. This time our score was 7. Previously it was 2. So we beat our high score. Let's play one more time. I got 1 point, and you can see it reset properly, and those are the high scores so far. The first round was 2, the second was 7, and the last one was 1. Let's make one final change. Let's go to our source directory, systems, and here where we handle game over, I want to use commands. And when we've received a game over event, I want to enter the game over state. So we'll say commands, insert resource, next state, app state, game over, semicolon. We need to import this. Oh, I made a mistake here. I need to wrap this in sum because this takes an option. If we cargo run now one final time, enter our game with G, and immediately when we get hit and the game is over, we go into the game over state and everything else is respawned. From here, we can hit G to go back into the game directly instead of having to go back to the main menu first. And there we go. Our application now has state. We've got a main menu, which we'll add UI to later. We've got our game state and our game over state that we're using. That brings us to the end of episode 9. We've covered another small refactor, state, enter and exit systems, running systems in a certain state or states, and run conditions. Still to come are UI, fixed time steps, optimizations, profiling, and many more examples. This episode has been both another concept-heavy video, but also a code-heavy video. I apologize the length got a little long. As I've been making this series, I feel like I've been walking a line between making a game and teaching Bevy, and you may be finding that as we're getting into these later episodes, the emphasis really is on learning Bevy. I think this is for the best, as my goal with this video series is to teach Bevy. Once the series concludes, I plan to create shorter series that cover how to make classic games using Bevy, and example projects implementing mechanics or features from other games using Bevy and ECS design. With that said, thank you all very much for watching. Please post your questions and any feedback down below in the comments. Thanks for watching, and see you in episode 10.